All right, this is lesson 431, radicals. In this lesson, you're going to learn how to simplify radical expressions, understand that irrational numbers cannot be expressed as the ratio of two integers, and you will learn to determine whether simple radicals are rational or irrational numbers. Quick review of a couple things that you'll find helpful in this lesson. Find the next three numbers in the sequence. You should notice that this number is 1 squared, 2 squared, 3 squared, 4 squared, etc. So the next three numbers would be 6 squared, which is 36. The next one is 7 squared, which is 49. And the next one is 8 squared, which is 64. Okay, find the area of a square if the length of each side is 11. So just a quick picture. Remember, a square is a rectangle, and a rectangle, the area is base times height or length times width. And since they're both the same, we're just going to do 11 times 11, which is the same as 11 to the second power, which is 121. Number 23, find the length of each side of the square if the area is 100. So in this one, we have a square. We know the area is 100, and we know that we can multiply the side by the side to get that. So side times side, or side squared, equals 100. So we're trying to think of what number multiplied by itself equals 100. And that is 10. 10 times 10 is 100. Now, I want to introduce you to something on your calculator that we're going to use a lot here. So remember, on the last problem, we were looking for some number multiplied by itself that equals 100. There's a key that does that. It's called the square root key, and it looks like this. Go second and x squared, and you get that. And then you enter the number you want to find the square root of, close off the parenthesis, press enter, and it tells you what number multiplied by itself equals that number. So that's going to be a handy calculator key that we're going to be using here. Which of the following numbers are solutions of the equation x squared equals 36? So that means the number times itself is equal to 36. So we have to try some of these. And some of you are thinking, well, I know 6 times 6 is 36, right? So 6 is a solution. There's one other one in there, though. Some of you remember, hopefully, that a negative times a negative is a positive. So we also have negative 6 times negative 6 is equal to 36. So negative is another solution. Negative 6 is another solution. So there are two solutions to this equation. All these other numbers aren't going to work. 4 times 4 is 16. 18 times 18 is, I think, 324. And likewise, those numbers won't work either. Okay? So fill in the values in the table. In this first one, we're just multiplying 3 times the input value x. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And once you see a pattern, you should be able to continue that pattern. 9, 12. This one, we're going to do the number multiplied by itself. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. The last one, we're going to multiply negative 2 by our input and then add 1. So negative 2 times 0 plus 1, that's 0 plus 1 is 1. Negative 2 times 1 plus 1, that's negative 2 plus 1 is negative 1. Negative 2 times 2 plus 1, that's negative 4 plus 1 is negative 3. And you can see that we are dropping 2 every time x goes up by 1, so we probably could continue this pattern. You might be saying, well, I noticed that this is linear. And in fact, since it starts at 0, 0, it's a direct variation. And the last one is linear, but not a direct variation because it doesn't start at 0, 0. And this middle one, that's a new kind of equation. That's actually called quadratic. I'll tell you that now, but you don't need to know that term yet. Eventually you will. All right. So, I said earlier we're going to explore radicals. And we're going to use our calculator to help us do that quite a bit. But radicals are any numbers written with a square root or a root sign like that. So why do you think these numbers are called square numbers or perfect squares? What do they have to do with the square? Well, let's just think about it. If the area of the square is 16, then the number multiplied by itself that equals that, which is 4, is the side length of the square. If the area of the square is 64, then the side length is the square root of 64, which is 8. If the area of the square is 100, then the side length of the square is 10. So now it says without using the square root key on your calculator, try to find the side length of a square whose area is 12.5316. That'd be pretty hard, but what we would be trying to think of is what number multiplied by itself equals this, and I don't know that off the top of my head. But we can tell that that if I do the square root of 9, that I can do in my head. That's 3 because 3 times 3 is 9. I can do the square root of 16 in my head. That's 4 because 4 times 4 is 16. So I know that the square root of 12.5316 is in between those two somewhere, because 12.5316 is between 9 and 16. So I don't know exactly what it is, but I do know that it's between 3 and 4. All right, so let's do some square roots. I'll give you a few examples, and then we'll do the rest in class. Find each square root, and you can use your calculator if you want, but I would suggest as much as you can to just try and do it without calculator, so you kind of get used to these numbers. But so what we're looking for, when you see the square root symbol, you should be thinking, what, so I'll just say the square root of A, what number multiplied by itself equals the number under the square root sign. So for this first one, we're thinking what number multiplied by itself equals 1, and that's 1. The second one has a negative sign, and that means we're talking about the negative square root. So that's going to be a negative number, and what number multiplied by itself equals 16? And that is 4. All right? And one way you can always check square roots is you would have to do 1 times 1, multiply the number by itself, and you get the number underneath the square root. Okay? On this one, you would multiply 4 times 4 to get the number underneath the radical, which is 16. This one kind of looks like it might be hard, but if you think of 25 as a fraction, it's 25 hundredths, and 25 hundredths, the number 25, you can think of what number multiplied by itself equals that. That's 5. And what number multiplied by itself equals 100? That's 10. And 5 over 10 simplifies to 1/2. So what we're saying is that the square root of 1/2 times 1/2 is the same as the square root of 1/4, which is the same as the square root of 25. All right? So on the next one, we can do the same thing. What number multiplied by itself equals 25? So essentially, we can split this up and say, I want to do the square root of the top number, and I want to do the square root of the denominator. And the square root of 25 is 5, and the square root of 36 is 6. All right. And to check it, when you do 5, 6 times 5, 6, that should give you the number underneath the radical sign, and that does 25 over 36. Okay. All right, I'm going to leave these for us to do in class. They're similar to the ones that I just gave you an example of. Okay, I'm just going to do a couple other problems here. It says, number 2 says, what are the square roots of 100? So it's kind of telling you that there's more than one. So remember, the square root means what number multiplied by itself equals 100. All right, and that would be, we know that 10 times 10 is 100. So 10 is one of the square roots. But we also know that negative 10 times negative 10 equals 100. So negative 10 is another square root of 100. So our answer is 10 and negative 10. Number 4 says, what are the square roots of 2.25? If you want to write that as a fraction, if you knew how to do that, you could figure this out with a calculator. But for this problem, I think I'm just going to go to my calculator and find the square root of 2.25. Now remember, it says the square roots. So what we're looking for is both square roots. One of the square roots is simply square root of 2.25. That's the positive square root. Enter, which is 1.5. And the other one is the negative square root of 2.25. So there it is, the negative square root of 2.25, which is negative 1.5. So what are the square roots of 2.25? 1.5 and negative 1.5. And we can represent those this way. Here's the positive square root of 2.25, and here's the negative square root of 2.25. What is, we can do that in class. All right. Now, let's just take one look at this problem real quick here. And instead of real numbers, how many square roots does a negative number have? So that would be like this. Does that have can you answer that? So what we're saying is, what number multiplied by itself equals negative 5? And since positive times a positive is a positive, and a negative times negative is negative, it is impossible. So we say this is under 5. All right. I think we can maybe do one more problem here, and then we're going to stop. But so think about this. Problem like this, where we have the square root of 2.25, and we square it. I'm going to do one where we know the answer like this. We know that the square root of 100 is 10. So really, that's just like saying negative 10 multiplied by itself. And negative 10 times negative 10 is 100. So check that out. That is the number that we have underneath the square root symbol. And that seems to make sense because multiplying a number by itself and taking the square root are really inverses of each other. X squared and the square root of x they undo each other. All right, that's the end of the video. I'll see you tomorrow.